Okay, we have here today a really interesting looking integral from the MIT Integration Bee 2012. This one's problem 10. We have the integral of x minus 1 over x plus 1 times the square root of x cubed plus x squared plus x dx. So to start with, the first thing that really jumps out is this situation here inside the radical. I mean, that's a problem right away because, so at first I tried factoring an x out of this, and what happened is then I had a square root of x floating around. I didn't really like that. So what I did instead is I wanted to factor an x squared out of this. So I'm going to factor this as x squared, and then what's going to be inside parentheses is going to be just x plus 1 over x. So now I'll go ahead and rewrite this. I'm going to keep my x plus 1 in the denominator. We're going to change this radical to this part, which is going to be x plus 1 over x. Now let's not forget this x squared. When I take the x squared out of the radical, that's going to give me an x, right? We'll pull this out as an x. But what I want to do is I'm going to take this x and divide it into the numerator. And so that's going to give me here 1 minus 1 over x dx. So the thing I think that's really tricky with this problem is like the u substitution is not obvious. It's not clear exactly what we do with the algebra here to make a nice u substitution. One thing I tried was a u substitution making this my u. But then when you take the derivative of this, you get 1 minus 1 over x squared, and it's not quite that. So I was kind of stuck there. So what I landed on for a u substitution, instead of making it just what's inside the radical, I decided to make my u this whole thing here. So let's do that. I'm going to call my u equal to, and I'm going to set it up so I can integrate it with power rule. So I'll write this as this to the 1/2 power, and then I'll take my derivative. This is going to give me 1/2 x plus 1 over x minus 1/2, and then we need the chain rule to take the derivative of what's inside here. That's going to give me 1 minus 1 over x squared dx. And then what I'm going to do is just solve this for dx. So we'll just take the reciprocal of everything. We're going to have 2 times this thing, but now we're going to have it in the numerator as 1/2, and then we'll bring this thing into the denominator. But just notice that this piece right here is actually the same thing as our u value right here. So what I'm going to do is we can actually write our dx a little simpler. We can write dx as 2u over 1 minus 1 over x squared du. And now I'll just go ahead and make the substitution, but I can't make the whole substitution right now. We're going to leave some terms in x, and we'll have to change them over in a minute. So we're going to mix x and u for a second. So then for our dx value, we're going to have 2u du, 1 minus 1 over x squared. And then again, this here is our u, and we'll leave this x plus 1 for the moment. Now the u's are going to cancel. I can bring the 2 up front. I can take this and use the difference of 2 squares on this, so I can write this as 1 plus 1 over x times 1 minus 1 over x. And I do that just to get some more cancellation, because then what's going to happen is this one's going to cancel with this one. And I do need to clean up the board, but one thing I'm going to do before we do that is I'm actually going to just multiply these two together, because we've basically canceled everything off. We're multiplying x plus 1 times 1 plus 1 over x. So let's distribute that out. X times 1 gives me x. 1 times 1 gives me 1. X times 1 over x gives me another 1. And then 1 times 1 over x will give me 1 over x. But what I actually want to do is I'm actually going to write it a weird way to make it match what we did with our u substitution. So I'm going to write it as x plus 1 over x plus 1, just separating out these ones. So I'm going to clean everything up, put this back in the denominator, and then we can continue. Okay, so now we've simplified things quite a bit, but we still have a major problem here, right? We're integrating with respect to u, and we have all this stuff still in terms of x. We can't integrate like this. We need to get everything in terms of u. Well, the nice thing is we have an expression over here. We have, notice this is the same thing as this. So all I need to do here, noticing that u is the square root of this thing, if I just square both sides, we can say u squared is going to be x plus 1 over x. And so at this point, we can kind of finish off our substitution, which has been taking a while, because we know now that this is u squared. So we're going to have du over just u squared plus 1. Well, that's really nice because this integral is actually arctan. So we can just integrate this, and we're going to find this is 2 times arctan of u. And so now at this point, I just need to back substitute to finish this thing off. So I'm going to write the final solution as just 2 arctan of u, bring back the square root, so it's going to be square root of x plus 1 over x plus c, and that's it. Okay, so good problem today. Again, something to look out for is the tricky u substitution, or the u substitution that isn't obvious. So we'll stop it there. Thanks everyone for watching today. Please like and subscribe. Have a great day.